Today we are going to learn about understanding proportional relationships. Lucky for you all, Mr. Beast has come along to help you understand. So, Mr. Beast, what exactly is a proportional relationship? A proportional relationship is when quantities have the same unit rate. For example, if I look at these two quantities, 10 over 2 and 15 over 3, let's pretend that they're talking about the cost of cupcakes. And the first quantity there says 10 cupcakes cost $2, and the second one, 15 cupcakes cost you $3. If you simplified both of those, you would see that they both give you a unit rate of 5 cupcakes costing $1. So yes, they would be considered proportional. You can also just divide to see if things are proportional. So when you divide values and get the same quotient, you would say they are proportional. So let's look at this table. We're always going to put the y first and divide by the x because that's going to give us our constant of proportionality. So let's look at the first row. We have a y value of 9 and an x value of 3. 9 divided by 3 equals 3. To see if the rest of the values in this table are proportional, we're just going to do the same thing. 24 divided by 8 is also 3. 33 divided by 11 is also 3. And 60 divided by 20 is also 3. In order for a table to all be proportional, every single row has to give you that same constant of proportionality. In this case, the constant of proportionality was 3. So yes, this entire table is proportionate. I should look at some examples. If you follow Mr. Beast, you may know that he's a very generous guy. On several of his YouTube videos, he gives pizza delivery men and women really big tips. So we're going to use this to create a question for us. Here are the number of deliveries and total tip amounts for different days in April that Mr. Beast decided to tip these huge amounts. My question to you is, do the tip totals each day show a proportional relationship? So in order to figure that out, just like we did on the previous slide, we're just going to divide. 30,000 divided by 3 would give you 10,000. In order for this table to be proportionate, every single row would have to equal the same when we divide. 40,000 divided by 4 is also 10,000. 60,000 divided by 6 is also 10,000. And 80,000 divided by 8 is also 10,000. So we would say, yes, it is proportionate. And what is that constant of proportionality? Exactly what you just divided by. The constant of proportionality would be 10,000. And yes, the answer above here would be, does the tip amount each day show a proportional relationship? Yes, of course, because every time you divide the y value by the x value, you get the same thing of 10,000. So yes. Now we're going to use the same information to show us how graphs can be proportional or not. We already know from the previous slide that this table does show a proportionate relationship. So what is that going to look like on a graph? Well, if you see here, on the bottom of the graph, I have the number of deliveries made, and on the y-axis, we have the total tip amount. In order for a graph to be proportional, it needs to have two things. The points must be in a straight line, and the line must go through the origin, which is the point 0, 0 right here. This is your origin, the point 0, 0. So if we were to take these points and draw a line right through them, it would look just like that. So yes, this graph shows a proportionate relationship because the line is perfectly straight and it goes straight through the origin. Example question number 2. Keeping with the same theme, we're going to talk about Mr. Beast's tips, but now we're talking about May. If you look at the table, you see the number of deliveries made and the total tip amount. My question to you is, now does this table show a proportional relationship? Remember, in order to figure that out, we're going to be dividing the values in this column, which are our y values, by the numbers in this column, which are our x values. So that first row is going to show me 10,000 divided by 1 equals 10,000. In order for this table to show a proportional relationship, we need to get that same number every time we divide. If you look at the second row, 30,000 divided by 2 gives me 15,000. Right away, that is enough to tell me that no, these are not proportional. These two numbers would have to be equal in order for this to be a proportional table. Now I'm going to do each row so you can see that just because that third row also equals 10,000, this is still not proportional because the second value, or the second row, gave me a different number. And that last row there, 180,000 divided by 6 is 30,000. So this is really not a proportional table because there is no constant of proportionality. All of these values would have to be equal in order for this table to be proportionate. Now, what would this look like on a graph? If I plotted all those points, that's what we would see. Does the graph show a proportional relationship? Well, you already know from the table that this is not a proportional relationship, but you need to know why. So if you just saw the graph, I would know this is not proportional for two reasons. Well, one, if I were to draw a line connecting the points, it's not straight. The other thing would be it doesn't go through the origin here. In order for a graph to show a proportional relationship, the line that is made by the points being connected has to be straight and it has to go right through the origin here. Don't be afraid of decimals. Mr. Beast there is looking kind of nervous, but don't be afraid. It's okay if your constant of proportionality is a decimal. Sometimes it's going to end up that way, and that's okay. Thumbs up from Mr. Beast. So here is our new data. Mr. Beast has set out in real life, he did this on a mission to plant 20 million trees. Amazingly, he not only met this goal, but he surpassed it. As of this morning, May 6th, his Team Trees project has funded the planting of 22,010,795 trees. That's pretty amazing. So using this as a theme for our next question, this table is showing the number of the amount of money donated per minute to his Team Trees project. And I just made up these numbers, but we're going to use them to just go along with the theme. So my question to you is, does this table show a proportionate relationship? Now remember, in order to figure that out, we're going to go row by row and divide our y value by our x value. So that first row, 25 divided by 2, gives us a number of 12.5. So if this table is proportionate, every time I divide my y value by my x value, I'm going to need to get that same value of 12.5. I'm okay if you use a calculator to do that. 75 divided by 6 also gives me 12.5. And 125 divided by 10 is also 12.5. So yes, this is a proportional relationship. Proportionate or not proportionate? That is the question that Mr. Beast is posing you now. But we're going to look at graphs this time only. So you're going to explain to me why these graphs are proportionate or not proportionate. First graph here, we're talking about how much you weigh on the moon compared to how much you would weigh on the earth. You're looking at that graph and looking for two things to see if it's proportionate. Does it make a straight line and does it go through the origin? Yes, 100%. It goes definitely a straight line and it goes right through the origin here. So this is a proportionate graph. Here's another graph that talks about the cost of theme park tickets. First thing, if I were to look at this, does it make a straight line? Yeah, if I were to have a ruler here and draw straight through it, even though I didn't do such a great job, that does make a straight line. However, it does not come anywhere near the origin here. So this is not a proportionate graph because it does not go through the origin. It does not matter if you have a straight line. If your line doesn't go through the point 0, 0, you do not have a proportionate relationship. That is one of the major problems and biggest mistakes I see on this is that people see a straight line and they're like, yes, it's proportionate, but no, it has to go through 0, 0 in order to be proportionate. The next graph here shows the number of ice cream sales compared to the temperature it is outside. Looking at this, is this a proportionate graph? Definitely not. It doesn't make a straight line. Even if you were to see that somehow it would go through the origin here, we were to continue, like if there was a point there at 0, 0, it's definitely not proportionate because it would not be a straight line if you tried to connect the points. You'd end up with something crazy that looks something like this. That's definitely not a straight line. So this is not a proportionate graph. All right, last graph here. The hiking distance and the amount of time it took, is this a proportionate graph? Remember the two things that you're looking for? And definitely yes, this is proportionate because it makes a perfectly straight line and it goes straight through the origin. All right, I hope Mr. Beast has helped you guys understand proportional relationships. If not, feel free to message me and with any questions that you have. Have a great day.